Hello. In this video, I'm going to show you how to convert from polar coordinates to rectangular coordinates and how to convert from rectangular coordinates back to polar coordinates. So let's get started. Okay, here I have a polar coordinate graph paper, and I'm going to plot the point 30 degrees. So on 30 degrees, this is 0, this is 90, so this is my line here that represents 30 degrees. And I'm going to count out 6 from the pole. 1, 2, 3, 4, 5, 6. So this point right here is the point 30 degrees. And since I want to convert it to rectangular coordinates, my rectangular coordinates are in terms of x and y. And when I drop a perpendicular down from this point, and I draw this along the polar axes, and this angle is 30 degrees, and r is 6, and this is perpendicular, that should look quite familiar to you. So we can see that this is x, and this is y, and if I want to find the value of, well, let's say x, then when I look at this triangle, I can see that the cosine of theta is x over r. So the cosine of 30 degrees is x over 6. The cosine of 30 degrees is the square root of 3 over 2. And that gives me, that's x over 6. Multiply both sides by 6, and multiply this by 6. Those will cancel out, and 2 goes into 6 3 times. So my x-coordinate is going to be 3 times the square root of 3. In a similar fashion, I'm going to look for the y value, and to find the y value, I know that that is the sine. So the sine of theta equals y over r. So the sine of 30 degrees equals y over 6. The sine of 30 degrees is 1/2, is y over 6. Multiply both sides of the equation by 6, and I get that 3, or y equals 3. I'll just reverse it. So then my coordinates for converting the point, the polar coordinate 30 to rectangular coordinates, will give me 3 square root of 3 for the x and 3 for y, and that's how we convert it. So we just draw in the triangle from the point. We just draw the triangle and use our trigonometry. And generally when we're converting points, we're going to use the ones that we can get exact values using the trigonometry, using the ones that we actually work with the most in the unit circle. So that's how we would convert it. We drop a perpendicular, make a triangle, and use our trigonometry. I'll do another example. Okay, again I have a polar coordinate plane, and now I'm going to plot the point for -45 degrees. So since it's negative, the angle is negative, I'm going to go in this direction, go in the opposite direction. So then this is actually -90, so -45 is going to be right here along this line, and I'm going to count out 1, 2, 3, 4. So my point for -45 degrees is right here. When I draw my perpendicular, I'm going to get this point right here. I'm going to get my triangle, and here is R, which is 4, and this is 45 degrees. And when I work with it, I'm actually going to work with it positive, the angle positive, but I'll know that this has to be a negative value. So this is my Y, and this is my X. So then, when I go to convert, this is R, and this is theta. So I have everything labeled. So now, just like in the previous example, my cosine, the cosine of theta is x over r. So when I plug in my values, I'm going to have the cosine of, if you want to work through with the negative, that's fine. So it's cosine of 45 is the x value over r, which is 4. The cosine of 45 degrees is 1. Now the cosine of 45 degrees is the square root of 2 over 2. Sorry about that. Equals x over 4. And then when I go to solve this for x, I multiply both sides by 4. And the x coordinate is 2 square root of 2 and equals x. And so then when I find the sine, so my sine of theta is y over r. So when I put in the sine of, if you want, it makes it more sense, I guess, if you do the negative 45. So then I'll see where the negative comes from. It's y over, and r is 4. So the sine of negative 45 degrees, we can see because it's going down, it's going to have to be negative. So this is negative square root of 2 over 2 equals y over 4. Multiply both sides by 4. And we get, that cancels and leaves us with 2. So we get negative 2 square root of 2 equals y. When we write it as an ordered pair, we're going to get the point 2 square root of 2, comma, negative 2 square root of 2. And when you think about that on the xy coordinate plane, you realize that it is in fact in the fourth quadrant. So it makes sense. It's very consistent. So to convert a point from the polar coordinates to the rectangular coordinates, just draw in the triangle and use your trigonometry to come up with the x value and the y value. Okay, here I have the xy coordinate plane, and I'm going to plot a point here, and then we'll convert it to polar coordinates. So let's suppose my point is 3, negative 3. So along the x I go 3, and then I'm going to go down 3 along the y-axis. So here's my point. Okay, so I have my x value. Here's my y value. And here's my r. And when I drop this perpendicular, here's r and here's theta, and the triangle should look very familiar to you. Okay, but we're going to use this, I'm going to just use an example, and then you'll be able to use this to convert anything from rectangular to polar. Okay, so I know my x value is 3, my y value is negative 3, and I want to find r. So I'm going to use the Pythagorean theorem. I'll put that up here, Pythagorean theorem. So I know that x squared plus y squared equals r squared. So my x is 3. Oh, I forgot to label the point. Sorry about that. My point is 3, negative 3, so x is 3. So I'm going to have 3 squared plus y is negative 3 squared equals r squared. So I have 9 plus 9 equals r squared. So I take the add that together, I get 18. Take the square root of 18, and that'll give me r. And that's 9 times 2, so I get 3 square root of 2 equals r. Okay, now I want to find the value of the angle. Now for the angle right here, my given values of x and y, I know that the tangent of theta equals y over x. So then my angle is the inverse tangent of y over x. So when I have that theta equals the inverse tangent of y, which is -3, over 3, which is -1. The inverse tangent, theta, equals the inverse tangent of -1. So the inverse tangent of -1 is the angle whose tangent, and so since it's in the fourth quadrant, then I'm going to say that theta equals -45 degrees, because that's where the inverse tangent is a function. So then my polar coordinates are going to be the point 3 square root of 2, comma, -45 degrees. Okay, but that's not the only, in the polar coordinates, that's not the only way I can write this. That's not the only set of directions, so to speak, that can give me this point right here. Now, let me go back and show you on the graph, polar coordinate graph paper. Show you something that's really neat working with the polar coordinates, because we converted the point 3, -3 in the xy coordinate plane to polar coordinates, and we got the point 3 square root of 2 and -45 degrees. But when we graph this on the polar coordinate plane, there's multiple ways, or that we can write, there's multiple ways we can get to that point. Another way we can get there is by going out here and going back to the negative. So to get to here, we can travel around to get to past the 90, halfway in between, and that's going to give us 135 degrees. So we can go 135 degrees and -3 square root of 2. Okay, this is also discussed in the video on plotting polar coordinates. So that's a second way we can get it. We can also go all the way around to here, and we can call this the point 315 degrees. We can get there by going 315 degrees and 3 square root of 2. So that's another way we can get to this point. And we can also go in the opposite direction, well, actually it's clockwise, to get to here and then come back. So we could go -3 square root of 2 and -225 degrees. Whoops. So we have 4 ways we can actually label the point that we got from one point in the xy coordinate plane. We get 4 options of how we can label it in the polar coordinate plane. Okay. But what we did for our technique is we plotted the point on the xy coordinate plane, drew in the triangle, and then we used the Pythagorean theorem to get r. We used the inverse, or the tangent, actually the inverse tangent, to come up with the value of the angle. And that's how we convert from rectangular to polar coordinates. I hope this helps.